Hi again. So we're continuing our review of the sampling distributions and working towards getting to the model we're going to use for our theoretical hypothesis test of a proportion. So we saw from the simulation in the last video that as long as certain conditions are met, we'll have a normal distribution. And someone also figured out formulas for exactly what the standard error will be in different situations, okay? So we're going to go over what those conditions are and then what the formulas are in this video, okay? So we saw, let me bring this up to the top here. We saw in our simulations that when we take the distribution of a statistic, like a mean or proportion, for many, many random samples of the same size from the same population, gets us close to a normal model, okay? And we've also seen that the mean stays the same as the population mean, but the standard error gets smaller the larger the sample size. Okay, now we've been pretending to know the population so we could understand this pattern, right? But in real life, we only take one sample. But this model lets us analyze how likely, how usual or unusual that sample is, okay? And what's the standard error of all those samples. Okay, so we're going to summarize the central limit theorem here for the sampling distribution of a proportion. Okay, so we're talking about a proportion, and so our one sample proportion would be p hat. And for every model, we're going to have conditions, and then the model means the shape or the formula. Okay, so we need to check these conditions for every situation to make sure we can use that normal model, in this case normal, and later on we'll use other models as well, but so far we'll be using a normal model. Okay, so independence. The individuals or items, the subjects in our sample must be independent of each other regarding the variable measured. Okay, so let's be independent regarding the variable measured. So just to stick with height, if we're measuring height, we need them to be independent in their height. And this series of videos, we're looking at health insurance. We need people to be independent in whether they have health insurance or not. Okay, then randomization. Oops, let me underline the title of that first one. Then randomization, just like you saw in the simulation, we were taking a random sample from each population. The samples need to be randomly chosen, or we also cannot assume independence. Okay. Okay, and then large population. So this has to do with if we're sampling without replacement, which is often the case, most often, but not always. Sampling without replacement means if you're measuring some parts or taking a survey, you wouldn't ask the same person twice, or you wouldn't measure the same part twice, okay? Replacement means you're putting it back in and they can be drawn again. So we're sampling without replacement. In that case, we must be sampling from a large population in order to consider the individuals independent of each other. And so you may have heard this called the 10% condition. That's another way to state it. Or the way I often state it is the population must be at least 10 times our sample size. Okay? So I'm going to explain more. I believe I have a video coming up. I'm going to explain this in more detail, why we need this. But for right now, I want to keep moving along with our conditions. The last one, and this is for proportions, success-failure condition. You should expect to have at least 10 successes and 10 failures in your data to ensure a normal distribution. And the way we measure that, we calculate this, check. We take n times p and n times q, and they must both be greater than or equal to 10. Okay? So this is getting to a certain sample size. In proportions, the sample size also depends on what p is. So I have another video where I'll go into this in more depth as well. But for right now, those are the conditions, and we'll practice them in this problem that we're doing. And then this is our model, okay? So, also let me say one more thing back here. Q is a shorthand for 1 minus P. So they're complements of each other, like 60-40, 70-30, 20-80, 50-50. They're complements. So you'll see that as we go. And so this is how we write a model. This is our notation for writing out a model. Okay, so this is our statistic. Okay, in this case it's p hat. And we say p hat with the tilde. What that means is distributed as. As distributed as, and then the letter is for the model. Okay, so N is for normal distribution. Okay, so we were saying that based on our simulations that we saw, and if these conditions are met, then our sample proportion is distributed with a normal distribution, and the first item is always the mean. And then there's a comma that separates the two, and these are the inputs to this function. The second thing is the standard error. Okay, so the square root is the standard error. Okay, great. So I know this is kind of a quick one, but I just wanted to go over the conditions and model, and then we'll go through the steps of the hypothesis test and do the test in the next video. Okay, I'll see you there.